So for section 9.3, we're now going to move into the series. So the first two sections were on sequences. This 9.3 now is talking about your infinite series. So just a reminder about the difference between a sequence versus a series. Remember, a sequence is a progression or an ordered list of numbers. However, a series is when you take those terms and you add them all together and you come up with a numerical value. So if you remember from Algebra 2 and Pre-Calc, we can use your sigma notation to represent sum. So this is our sigma notation, so we're taking the first term to infinity and we're going to add all these terms together. So remember, this sigma notation means a sum. And then again, we have the individual terms of the series that we're adding together. In most cases, we're not going to be actually to calculate the infinite sum, even if we know that one exists. We can start, though, by looking at the sequence of the partial sums. So suppose we have this particular series. The first partial sum, when we talk about a partial sum, the first partial sum is just the first term. The second partial sum is found by adding the first two terms together. The nth partial sum is the sum of the first n terms. So for example, to find the sum of just your partial sum of 1, it's just going to be 1/2. The second partial sum would be found by taking your 1/2 and adding it to 1/4. So 1/2 plus 1/4 is going to give me 2/4 plus 1/4, which is a 3/4. Your third partial sum would become from finding the sum of your first three terms, 1/2 plus 1/4 plus 1/8. Again, I know what my second partial sum is, that's 3/4. So 3/4 plus 1/8 is going to give me 7/8. And then my fourth partial sum will be found by adding the first four terms together. So 1/2 plus 1/4 plus 1/8 plus 1/16. Again, I know that the partial sum of the first three terms is 7/8. Add 1/16 to that, and that's going to give me 15/16. So then, to find the sum of S sub n, I can use my sigma notation. So k is equal to 1 to infinity. Actually, I should use an n, excuse me, because they're saying S sub n. 1/2 times, again, coming up with a pattern for this, it's going to be 1/2 to the n minus 1. So if you look back, remember for your series, this is what we refer to as a geometric series. There is a common ratio. Notice each term is increasing if you multiply by 1/2. So to find the limit as n is going to infinity, I can find the sum of my infinite geometric series. Remember, the formula is your first term divided by 1 minus the common ratio. So my first term is 1/2 divided by 1 minus the common ratio of 1/2, which is just going to give me 1. You can find sums on your calculator. If you have a TI-83, these are the steps that you can use. Remember, if you have your 84s, with the updated operating system, you can find your sigma notation. By going under alpha window. Alpha window option 2. So that's how you can find the sum of a series. So like I said, you can go under alpha window. And then you can type in using your series notation. That's where you can find your sigma. So we talk about partial sums, or if you have a sequence that's converging to a limit, then we say the series is going to converge to S. And that is the sum of the series. And again, we can use your sigma notation. If the sequence of the partial sum, diverges, then the series is said to diverge. A divergent series has no sum. So there's lots of different series we're going to be taking a look at. And the one that you're most familiar with, and I just mentioned, is the geometric series. So if you remember, not all infinite geometric series will have a sum. So again, we're only talking about the infinite series. And remember, your rule to find the sum of an infinite geometric series is that it will converge if the absolute value of your common ratio is less than 1. Or it will diverge if the absolute value of common ratio is greater than or equal to 1. So this is, remember, the formula to calculate the sum of your infinite geometric series. You take your first term and divide it by 1 minus r. So determine whether, so they're telling you that you have a geometric series. So remember the explicit formula for your geometric series. It was a sub 1 times r to the n minus 1. That's what the explicit formula for your geometric series looks like. So if whenever possible, if you have a formula given to you, see if you can express it in this way, or you could write out the first couple terms. So if you take a look here, the quantity of negative 5 over 4 to the k, I can rewrite this in the form of, where's my sigma, k is equal to 0 to infinity. I can rewrite this as a negative 5 times 1/4 raised to the k power. So because I can write it in this form, or what I can do is I can write out my first couple terms. So again, if I plug in 0 for k, well, that's going to give me 1. That's going to give me negative 5. If I plug in 1 for k, that's going to be negative 5/4. If I plug in 2 for k, that's going to give me a negative 5 over 16, and so on. So you can see how your common ratio is going to be 1/4, and your first term is going to be negative 5. So again, if I find my common ratio is 1/4. So the absolute value of 1/4 is less than 1, so this series is going to converge. Now, if it converges, they do want me to find the sum, so I'm going to find the sum of my infinite series by plugging into my formula. Your first term in this series is negative 5, divided by 1 minus your common ratio of 1/4. So I have negative 5 divided by 3/4, which means I'm going to multiply by 4/3, so that's going to give me negative 20 over 3. So looking at B, it's not going to be as easy to write it in this particular form. So the easiest way to recognize the common ratio is just to write out the first couple terms. So if I plug in 1 for k, that's going to give me 3 squared times 5 to the 0. So 3 squared is going to give me a 9. My second term is going to be a 3 to the 4th, which is 81, over 5 to the negative first power, which is going to give me 81 times 5 to the negative first, or 81 over 5. Because they're telling me it's geometric, if you notice what you're doing to 9 to get you to 81 and it's divided by 5, I know that I could actually write this in my sigma notation as k is equal to 1 to infinity of 9 times 9 over 5, raised to the k minus 1 power, because we need that to be 0 to get that first term to be 9. So right here is my common ratio. So the absolute value of my common ratio has to be less than 1 to converge. So if I take the absolute value of 9/5, 9/5 is greater than or equal to 1, therefore this is going to diverge. So it has no sum. If you take a look at C, again, if I list the first couple terms, this is going to give me a 1/2 minus 1/4 as one term. My second term would be 1/4 minus, excuse me, 1 over 2 to the 3rd, which would be 1/8. And then my third term would be 1 over 8 minus 1 over 16. So when I simplify this, 1/2 minus 1/4 is 1/4. 1/4 minus 1/8 is going to give me a 1/8. And then 1/8 minus 1/16 is going to give me a 1/16. So as you can see, your common ratio is going to be 1/2. So then in sigma notation, I could write this as k is equal to 1 to infinity of 1/4 times 1/2 to the k minus 1. Again, my common ratio is a half, so to converge, I know the absolute value of the common ratio has to be less than 1. So I know that the absolute value of 1/2 is less than 1, so I know that this series is going to converge. So to find the sum of this infinite series, I'm going to take my first term, which was a 4th, divided by 1 minus the common ratio. So 1/4 divided by a half multiplied by 2 is going to give me 1/2. Okay. So then when I take a look at D, again, if I find the first term, again, plugging in a 1 for K, that's going to give me a 4/9. The second term is going to be found by taking -2 and raising it to the third, which is -8. And then 3 to the third is going to be 27. So then my first term is 4/9. My common ratio is going to be -2/3. So the absolute value of -2/3 is indeed less than 1, so I know that this series is going to converge. So then to find the sum, I'm going to take my first term, which is 4/9, divide it by 1 minus the common ratio. It's not the absolute value of the common ratio in the formula, it's just the ratio. So 4/9, 1 plus 2/3 is going to give me 5/3, which means I'm going to multiply by 3/5. That gives me 4/15. So that's how you can tell if you have a geometric series, that's how you can tell if it's going to converge or diverge. Here's an application problem of a geometric series. Find a rational number. So what that means, it wants you to find the fraction that produced this particular repeating decimal. So your repeating decimal 0.51515151 can actually be written as a sum. We can break this up into 0.51, add it to 0.0051, add it to 0.00051, etc. So this is a geometric series. Because again, what we can do to find the common ratio, you can take a term in the series and divide it by its previous term. So if I take 0.0051 and divide it by 0.51, notice that gives me a common ratio of 0.01. And I could do that with any term in the sequence and divide it by its previous term. So I do have a common ratio. So then remember, this is coming from taking the sum of all these. So remember, the sum of your infinite geometric series comes from your first term divided by 1 minus r. We know what the sum is. It's this 0.515151. Is equal to the first term, which is 0.51, divided by 1 minus your common ratio. So if I take 0.51 and divide it by 1 minus 0.01, that gives me 0.51 divided by 0.99. And that gives me the fraction 51/99. And so now let's take a look at another example, another application of a geometric series. So use the geometric series to show that k is equal to 0 to infinity of -1 to the k, x to the 2k converges between -1 and 1. So again, anytime they talk about the geometric series converging, you know that the absolute value of your common ratio has to be less than 1. You also know that the sum is going to be your first term divided by 1 minus r. So first of all, what I need to do is I need to find my common ratio. So I need to take a term and divide it by its previous term. So with this particular series, if I plug in 0, this is going to be -1 to the 0, which is 1. X to the 0 is 1. So my first term is 1. When k is equal to 1, I end up with -1 times x squared. So that's going to be a -x squared. So then to find my common ratio, I'm going to take -x squared and divide it by 1, which gives me -x squared. So there's my common ratio. So remember, to converge, the absolute value of this ratio has to be less than 1. So now the absolute value of -x squared has to be less than 1. So then x squared is going to be less than 1. So now remember how you solve quadratic inequalities. You want to make sure you have a 0 on the right-hand side. so x squared minus 1 is less than 0. You factor to find your critical numbers, and my critical numbers turn out to be -1 and 1. We're not inclusive. Again, what I want to know is I want to show that x squared minus 1 is less than 0, so I'm looking for the negative intervals. Well, if I plug in -2, a negative times a negative is a positive. If I plug in a 0, 0 minus 1 times 0 plus 1, that does give me negative. If I plug in 2, that's a positive. So you can see now that this is going to converge for your x values between -1 and 1. So now the next one is, my pen bled through really bad, so let me go get a clean packet. Sorry, my pen just bled through so bad, so I want to make sure we could see this. So now, find all the values for x which the series converges, and find the sum of the series for those values. So, first of all, let's determine that this is geometric. So let's notice what's happening. What am I multiplying my numerators by? Everything's getting multiplied by 2. The denominators are increasing by exponent of 1 for x, so that I'm going to multiply the denominator by x. So my common ratio then is going to be 2 over x. So then to converge, remember the absolute value of 2 over x has to be less than 1. So again, to solve this, what I'm looking at is I want to show that 2 over x is less than 1. So again, I need to get a 0, and this is a rational inequality to solve, so I'm going to subtract 1, so 2 over x minus 1 has to be less than 0. So when you solve a rational inequality, remember, you want to condense this to a single fraction. So this would be 2 minus x over x. It has to be less than 0. So again, do your number line test. You want to find your critical numbers by setting the numerator equal to 0 and the denominator equal to 0. So your critical numbers are going to be 0 and 2. Again, I want to show that we're less than 0, so the negative intervals will be my solutions. So if I plug in a -1, that makes the numerator positive, and -1 would make the denominator negative. So this is negative. Plug in a number between 0 and 2, that's going to be a 1, which is positive. Plug in a 3, that will be negative. So again, where is the values of x this is going to converge? It's going to be from -infinity to 0 and from 2 to infinity. So now to find the sum, I have to use my formula, a over 1 minus r. Again, my first term is going to be 1 over x squared divided by 1 minus my common ratio, which is 2 over x. Simplify your complex fraction by multiplying everything by x squared, so that's going to give me 1 over x squared minus 2x. So there's your sum of that particular series. So here's sine of x minus 1/2 sine squared of x. Again, the first thing we want to do is find your common ratio. Again, you can take a term and divide it by its previous term, if you're not sure what the common ratio is, by looking at the terms in the sequence. So that's going to give me -1/2 sine x. So then remember, to converge, the absolute value or common ratio has to be less than 1. So the absolute value of 1/2, -1/2 sine of x, has to be less than 1. So then I know that the absolute value of 1/2 sine of x has to be less than 1. Remember when you solved less than absolute value inequalities from Algebra 2, we can rewrite this as -1 less than 1/2 sine x less than 1 to solve those absolute value inequalities. Multiply by 2, -2 less than sine x less than 1. Excuse me, less than 2 when you multiply everything by 2. Now remember, the range of sine of x, the parent function, is just going to go from -1 to 1. So then what I know is that I know that this is just going to converge from -1 to 1. -2 is outside the range of sine of x. So to find the sum of this series, I'm going to take my first term, which is sine of x, divided by 1 minus the common ratio, which is negative 1/2 sine x. I can multiply everything by 2 to give me 2 sine x over 2 plus sine x. So that's your geometric series. Now, there's other special series that we need to talk about, and one is your telescopic sum. So a telescopic sum is recognizable because it's going to have a pattern where you're going to notice that when you list out some terms, you're going to see that terms are going to start canceling out. In fact, when you simplify the sum, one term in each parenthesis cancels with one term in another parenthesis until the entire sum collapses into just two terms like a folding tail. So it basically just starts collapsing. You have to just look at the sequence and decide which series and decide which terms are canceling out and which one remains. So the sum of a telescopic series is going to be whatever term is left. Notice it's not always going to be the first term minus the last term. You must write out the first few terms and decide which terms cancel and which terms remain. Now, as we move into a lot of these series, a big hint. If a question asks what a series converges to, because a lot of these series we're going to study in this chapter, they're never going to ask you about what it converges to. They just want to know whether or not it's converging or diverging. But they ever want to know what its series converges to, that's when you know the series is going to be a telescopic or geometric. These are the only series that they're going to ever ask you what this series converges to. So if the question ever asks you what a series converges to, you need to check for telescopic or geometric. I'll go back to this page so it didn't bleed through. So determine whether the series converges or diverges, and if it converges, they want you to find the sum. So what I'm going to do is write out the first few terms. Now when you're writing out, if you think it's telescopic, don't simplify. In other words, leave it as a 1 over 1 or a 2 over 2, etc., so you can notice the pattern. So if I plug in 1 for n, that's going to give me a 1 over 1 minus 1 plus 2 is 3. So that's your a sub 1. A sub 2 is going to be 1/2 minus 1/4. So that's your second term. Plug in a 3. There's your 1/3 minus 1/5. Your fourth term, 1/4 minus 1/6, and so on. So what you see here is you notice you can see in each set of parentheses I have a negative 1/3 here and a positive 1/3 here. That's going to cancel. I have a negative 1/4 and a positive 1/4. And if I kept going, you would see I'd have a positive 1/5 and a positive 1/6. So the only terms that are remaining are the 1 and the 1/2. So it is going to converge by telescopic sums. And the sum is going to be the two terms that are left added together. So 1 plus 1/2 is going to give me 3/2. So that's what the series is going to converge to.